Okay, for the shape of index of summation, if we have summation of n times x to the power n minus 1, where n is equal to 1 to infinity, and we want to write this summation in the term of x to the power n. In this case, we got to do the shift of index of summation by replace this n equal to n plus 1. Okay, we are going to put n here with n plus 1. In that case, we would get x to the power n. That means every n right here, every n here, we will replace it with n plus 1, and this is called the shift of index of summation. We'll get, we put n equal to n plus 1, which is equal to n plus 1 equal to 1, then n is equal to 0. By doing this, we would get x to the power n. At the first time, we got x to the power n minus 1. When we do the shift of index of summation by placing n equal to n plus 1, then we would end up with another new term that we got x to the power n. Another example, if we have x to the power n plus 2, and we want to write it in the term of x to the power n. We have summation an times x to the power n plus 2, and we want to write it in the term of x to the power n. In that case, we got to replace this n with what? N minus 2, right? If we put this n equal to n minus 2, we would get x to the power n. Okay. And by doing that, we'll get n minus 2 equal to 1 till infinity, an minus 2 x to the power n minus 2 plus 2, which is equal to n minus 2 equal to 1, n equal to 3. This is called the shift of index of summation. Now, we are going to find the solution of this differential equation by using the power series method. Okay. To do that, we assume y is equal to summation x of n equal to 0 to infinity a n x to the power n. This equation we have the first order of y. So we'll do the differentiative of y. The first differentiative of y is equal to summation of n equal to 0 to infinity of a n. What if we do the first derivative? What will we get? N x to the power minus 1. Okay, and then we replace y and the first derivative of y back into our differential equation. So we'll get x squared summation a n times n x to the power n minus 1 equal to this term I have x squared here, I have x to the power n minus 1 there, so I just put x squared into the summation sign. What do I get? X to the power, right? Which is equal to and then I just move the summation term to the same side. Now this one I have n plus 1 and this one I have n. So I'm going to do the shift of index of summation of the term, the first term, x to the power n plus 1 to be x to the power n. Okay. I'm going to do shift of index of summation. Make x to the power n plus 1 to x to the power n. In order to do that, I have to replace n with what? N minus 1. So I would get summation n minus 1 equal to 0, a n minus 1 sine n minus 1 x n minus 1 plus 1. N minus 1 equal to 0, n equal to 1. Now can we do subtract these two terms together? Can we do it? No, we can't. Why? Because this one n is start from 1 and this one n start from 0. Okay. So what we are going to do is just that we are going to put both terms into the same n, starting with the same n. And another thing is that if you put n equal to 1 here, you would get what? 0. So I put 0 there, n equal to 2. Right, because the first term is equal to 0, so you don't need to start from n equal to 1, because we know that it's equal to 0. Just put it right there. And now this way, if you plug n equal to 0, what you get? A0. If you put n equal to 1, you would get a1x. And if you put n is equal to 2, then you would get x squared, which is starting the same term of this one. So it is the rest I put as the summation of n equal to 2 until infinity a n x to the power n. Okay, now just going to arrange the term. That minus a0 minus a1x plus summation n equal to 0 until infinity. And then this term and this term is just starting with the same number until infinity, and we have x to the power n the same. So we can put them together. To put them together, it makes us get this term an minus 1 times n minus 1 minus an, the whole thing times x to the power n is equal to minus 1 minus x plus 0 x to the power n. We are going to do the comparing of the coefficients. Okay, the first term is x to the power 0. We compare the coefficient, we would get minus a0 equal to minus 1, right? So that means a0 equal to 1. And for the term of x to the power 1, we would get minus a1 equal to minus 1. So a1 is equal to 1 again. And the last term, which is the x to the power n. The x to the power n, we get, now, we got to consider x to the power n can't be 0. So only the number inside the parentheses should equal to 0. So in that case, I would say an minus 1 times n minus 1 equals minus an equal to 0. This is true whenever n is greater or equal to 2. So now your n got to start with 2. Okay. And from this, I would say that my an is equal to an minus 1 times n minus 1, where n got to be greater than 2, greater or equal to 2. So just assume n is equal to 2, my a2 is equal to a1. And n is equal to 3, a3 is equal to a2 times 2, 2 times a1. n equal to 4, a4 is equal to a3 times 3, which is 3a3, 3 times 2 times a1. And a1 is equal to 1, right? Which is equal to 3 factorial. 2 times 1, which is equal to 2 factorial. 1, which is equal to 1 factorial. n equal to 5, a5 is equal to a4 times 4, which is 4 times 3 factorial, which is 4 factorial. n is equal to 6, a6 is equal to 5 factorial, right? So our an is equal to n minus 1 factorial.ถูกไหมคะ? Because a2 is equal to 1 factorial, a3 is equal to 2 factorial, a4 is equal to 3 factorial. So an got to be equal to n minus 1 factorial, right? And then because we assume that our y is equal to summation an x to the power n, so we got a0 plus a1x plus a2x squared plus a3x to the power 3 plus a4x to the power 4 and so on. A1 is equal to, A0 is equal to 1, A1 is equal to 1, A2 is equal to 1 factorial, A3 is equal to 2 factorial, which is equal to 1 plus x plus summation m is equal to 2 to infinity of n minus 1 factorial x to the power n, right? N equal to 2, you got x to the power 2, 1 factorial x. X to 3, n to 3, 2 factorial, 4, 3 factorial. Okay. So you would end up with this. So the solution of this is y is equal to 1 plus x plus summation of n minus 1 factorial times x to the power n, where n started from 2 to infinity. Now we are going to check the radius of convergence, which is the limit of n go to the infinity of an divided by an plus 1. Now our an is equal to n minus 1 factorial and an plus 1. You put n equal to n plus 1 there, you would get n factorial, right? N minus 1 factorial divided by n factorial equal to what? N minus 1 factorial. N factorial is n times n minus 1 factorial, right? Which is equal to limits of n go to infinity of 1 over n, which is equal to 0. Except that if radius of convergence equal to 0, so that means the series converges only at x equal to 0. In our case, x0 is equal to 0. So that means this answer is true only when x is equal to 0. So this is not the case. So it's not really the answer of this differential equation. So we've got to take a look at this point, that what if the answer is not true for other x? How would we solve this problem?